Hello, everyone. My name is Scott. I'm in a group with Ann and Vanilla. We decided to do a project on the anti-vaxxers in the world and those who tweet in specific, and how quickly the movement seems to be taking over. A little bit of background on the anti-vaxxers and social media. As we all know, social media is kind of a double-edged sword. It provides opportunities for growth and an endless fountain of information. Although when it's abused, it can be wielded to the detriment of us all. Back in 2016, after the election, bots and political trolls had a big field day on it. They didn't disappear at all. They kind of reinvented the way bots were used. Researchers at George Washington University found Russian trolls to be using vaccination as a wedge issue. They kind of attempted to erode the public faith in the established norms. Russian trolls from the 538 data set tweeted 22 more times more frequently than the average user about vaccination. This slide shows the 538 data set of tweets and how likely these groups tweeted with vaccine keywords. Our goals going through all of this, we weren't that concerned with explanatory factors like the behavior, but any ideological polarization should be observed and evaluated for potential public risks. We wanted to perform a qualitative analysis of vaccine-related tweet content and determine general weight of its message, whether it's positive, neutral, or negative. We also wanted to identify or predict current and future trends, basically post-2018 for anti-vaxxer bot activity, and evaluate whether there exists any correlation between a more saturated anti-vaxxer online presence in Twitter and an increase in NMEs and regional outbreaks. NME is a non-medical exemption. So for the 538 data set, is a very, very large data set of almost 3 million tweets, mixed languages, all identified as part of the Internet Research Agency's Troll Factory. It spans from 2012 of February to 2018 in May. It was acquired by using Social Studio, which is an enterprise scraping tool / search engine. It has 2,752 unique handles in this data set, and there were 9 separate CSVs that needed to be merged. So when we were looking through our data sets, we obviously had a few issues. Since it's almost 3 million tweets, we noticed that there were plenty of missing data points, a lot of irrelevant features that were collected. There was non-traditional evaluation criteria and poor naming conventions. And again, this could be due to the fact that just because, there are so many people that tweet that don't really use full words, full sentences, not correct punctuation, it's pretty hard to figure out exactly what they're trying to say. So in this slide, it was kind of how we made sense of everything and our methodology of doing it. We used a rudimentary sentiment analysis that kickstarted our evaluation of the mass tweets. Our original hypothesis was that a pattern would emerge from the data set as we process the relevant material. So we were not married to one particular model. Obviously, we wanted to have certain criteria, that data points and whatnot. As mentioned previously, we approached our research question from the top down. We casted a wide net until we could refine and tailor our methods. A Python-based script was used to conduct a cursory analysis of the lump set to ensure enough actionable data was present. We then began data cleansing using traditional libraries and toolkits. The data frame was rearranged and assigned additional features. A secondary data set, which was a subset of the parent, was used as a statistical significance and an overlay with the NME data frame. Density-based clustering model DBSCAN was then used. As far as us, when it comes to removing the junk, we concatenated the 13 data sets. We dropped duplicate posts, which was about 20% of the material. English and Russian made up 91% of the data, but we actually dropped the Russian part for this study. Unknown clusters were dropped, material that was not relevant. We left the original analyst categorical system, right, left troll grouping, puremonger, hashtag gamer, and newsfeed until its utility could be better determined. The tidied version was then exported with a new CSV file for visualization. So the final set that we finally came down to was we had 14 features that remained in the final and primary data set, though we only used 5, which was content, published data, followers, account category, and SA, which is sentiment analysis, which was you got -1 for a negative sentiment, 0 for neutral, and 1 + 1 for a positive statement. The importance of choosing the appropriate visualization is it's pretty important. It's the slides a few slides ago showed a pie chart, and in our situation, the pie chart that we originally found was not good. We had to find one that broke down it into the negative, neutral, and positive pie chart. So this is what we came up with. All the tweets that we put together, the percentage of positive tweets was 29.6%, neutral tweets was 51.1%, and the negative tweets were 19.2%. So our next steps for the rest of our project, we need to obtain a sample of regular Twitter activity and compare it to the 538 data set. We need to try to look for hotspots of activity from people who support the anti-vax movement and draw insights from area clusters and potential outbreaks. The issue with that is a lot of people nowadays turn off their location, so it's kind of hard to figure out where the anti-vaxxers are tweeting from and if there are any outbreaks in that area. We would like to focus more on geolocation, but like I said, it's not always that easy. And that is it.